All right. Before I do number 7 in the warm-up, we're going over the warm-up. You'll check your homework. And then we have short notes today. You should have about 20 minutes of homework time today. You really shouldn't have a lot of homework, okay? I'm doing that. It's more of a classwork homework so that you guys can ask questions on it and be prepared for your quiz tomorrow. I will be able to answer remind messages or text messages tomorrow. I'll be in the car for about 6 hours, so I don't know how well my internet's going to work to get emails. So if you need me tomorrow, remind message or text message me, okay? And I'll put my number up, my Google Voice number up in the announcement again. A baseball field. We're going to educate everybody. I'm not making fun of you to be mean, so no one get their feelings hurt. A baseball field is a diamond. The infield is a diamond. The infield means the front part of the field. A diamond is just a sideways square, which is why all the bases are diamond shaped, because they make 90-degree angles. Thank you. You just set it down though. All right, then you have the outfield. It's typically curved, doesn't have to be, but it is typically curved because it has a fence that goes around it. When you hit the ball over the fence, it's called a home run. Just make sure we all know. Extra credit. What's it called when you hit a home run and the bases are loaded?
Grand slam.
Grand slam. Good job. It's okay. Let's go. Natalie's like, yes. Girl, then. Okay, I'm not going to make fun of you. I'm not going to make fun of you. All right, kiddos. Left. This is on the left, right? This is called left field. This is in the middle. It's called center field. And this is on the right. So it's called right field. Okay. This was an old exam question. This is why I'm really trying to explain it to y'all just in case, because you never know. So it says the distance from home plate to the fence in dead center field. That means all the way up here. This distance is 280 feet. I'm going to write it up here, but it's that whole distance right here. This whole thing is 280 feet. All right, then the distance between all of the bases is 60 feet. We're talking about Little League. So everybody look, third base to home base, 60 feet. Home base to first base, 60 feet. So everything in the infield, all the bases are 60 feet apart. That's the side to the square. Is everybody okay with that part? Yes? Okay. My in-class people are saying yes. People at home, are we good?
Yeah.
Yes, ma'am.
Okay, so then it says, how far is it from dead center field to third base? So here's dead center. Here's third base. We want to find this green distance. If you look right here, does everybody see this triangle that we just made?
Yeah.
Okay, so we know this side is 60. We know this side is 280. And we should also know this angle right here. What would this bottom angle be?
450.
45 degrees, because it was a right angle and we split it right down the center because we went to center field. So you split it in half, so it's 45. So does everybody see how we have a side, an angle, and a side? If they give you side, angle, side, what do we use? Law of sines or law of cosines?
Cosines.
Cosines, good. You'll have to know that on your quiz tomorrow. It doesn't tell you which one. I recommend drawing the picture, looking at your picture. Did they give me angle, angle, side, angle, side, angle, side, angle, side, or side, side, side? That'll tell you what to use, okay? All right, we're trying to find a side. Who can help me set up my equation?
$60 squared plus 280 squared
Good. Y'all can keep talking in class too.
Minus
minus
2
2
times 60
2
times 280 times 280.
Good.
times
Cosine
the cosine.
45.
Yeah.
Good. Good job, you two. Good job, you two. Extra credit. Are we okay with that? Okay, did y'all go put this in Desmos? And then did you take the square root? Yes.
Yeah.
Okay.
Yes.
What'd we get? What's the distance from third base to center field? What'd we get?
234.52.
I got 241.33. No, you're right, because I did it again. That's what I've gotten every year that I've done this worksheet. I always do a worksheet. I won't give y'all something that I haven't worked out ahead of time because it used to piss me off when my math teachers would give us problems that wouldn't work or if there were mistakes. Kayla's back there like, yep, that do make me mad. I always work out stuff that I give y'all. There's always a key. Always make sure it works good. Do we need to see me type this in? Kevin, did you use a calculator?
Yeah.
Did you put parentheses around this back part right here so that you did the multiplication first?
No, I think I like messed up when I was trying to like condense it. So.
That's probably. Make sure you do the multiplication first if you're using a calculator. But again, that's why I like Desmos.
Miss Poole,
Put it all in at once. Yes.
I forget when you can use the rounded decimal when like we're doing them.
So it's when, that's a good question. Extra credit. Listen to me very carefully. If the question is only asking for one piece and you can find that piece in one step, then you're done. You can go ahead around, it's over. If the question asks for multiple things or it takes you multiple different calculations to find what they asked for, then you don't round until the end. Does that make sense, Grace?
Yeah.
That was a great question. Any other questions on the warm-up? I can't believe we've done 42 pages of notes already. Everybody good? Can I flip? All right. Drake's so proud of me. Kayla, did you see that? Girl, swish. Right there. I should have gone. I'll go for the far one next. My markers are done. I've missed once. Yeah. Y'all just didn't see it. So I could have lied and said no. All right. You guys just told me area of a triangle, what you learned in middle school, was 1/2 base times height, or Grace said base times height divided by 2, right? Okay. Perfect. All right, so let me give y'all just an example from Math 2 of how y'all found area of a triangle. Just want to see what we remember so we can play off of your previous knowledge. Can I find the area of this triangle? Okay, good. Y'all are saying no. Why not?
That's not the height.
You don't know the height. This is not the height. I also didn't give you that anything was a right angle, so we don't know that either, okay? So you don't know the height. If I gave you an angle, this is what you guys used to see in Math 2. Could we find the height? Yeah, right? Hopefully, I'm seeing some head nods. We could find the height here, and then we could do the area. Okay, beautiful. So let's just review. How would you find the height? What could I use?
Pythagorean theorem.
Not Pythagorean theorem, because this whole bottom piece is 8. Good. KJ said SOHCAHTOA. You know this angle is 32 degrees, right? Then we're trying to find the height, which is the opposite side. And we know the hypotenuse of this small green triangle. So this is just me reading y'all's faces and reading how y'all have done on homework. Y'all are great with law, sines, and cosines. Some of y'all don't remember how to do SOHCAHTOA. There's SOHCAHTOA word problems on your test. We got to make sure we're okay with setting up opposite over hypotenuse and finding the height. Yes. It is, because this is when you draw the height down, this is a 90-degree angle. Yep. Remember, height is always vertical. So it's going to make a 90-degree angle when you draw it down, okay? So if I do sine of 32 degrees, the opposite side is the height. That's what I want to find. And the hypotenuse is 5. So how would you find the height? What would you do? You would multiply the 5, and so you would get 5 sine of 32 degrees, correct? Okay. And whatever that is, that would be your height. And then could you do 1/2 base times height? All right. How many of you are trying to do SOHCAHTOA every single time there's an area problem to find the height? Because they don't give you the height in pre-cal. Anybody? I wouldn't. There's a formula. You're going to do, to find the height, you're going to do the same thing every single time. You're going to take the sine of the base angle, and then it's going to be opposite over hypotenuse, so you're going to have to multiply that by that hypotenuse. You're going to get something like this every single time. So I'm going to draw y'all a more general picture that just has letters so we can see where this formula comes from, okay? I feel like I lost some of you. Talk to me. What do you mean, what's the bottom side? Yeah, that's the base of the whole triangle. This is the base, this is the height. You're fine. Your teacher was out when you were in math too, so you're okay. All right, so this is where the notes come in. If we know two sides and their included angle, which means we know what? Good, KJ. Side angle side. If you know two sides and the angle in between them, that's called side angle side, right? So if you know side angle side for any triangle, the area can be found by this formula right here. And then we're gonna derive it together so y'all can see where it comes from. One half AB sine of gamma, which we know is just is C. So 1/2 AB sine of C. So let's draw a picture that looks similar to our one we had above when everybody's good. All right, let's look at this brown triangle. Can we find the area of this triangle? Not yet, because what do you not know?
Anything.
Okay. You could write an expression for the area using A and B. So let's not think that it just has to be numbers. You have variables. What am I missing that I have to find area? H, the height. Look at this blue one up here. It's just like this one. You don't know the height. Does everybody agree with that? Yes, great. Thank you, Pradnia. All right. How could we find the height? Good. This is a 90-degree angle. So I heard somebody say it's a right triangle, which means we can use SOHCAHTOA. I think my Oswald just said we can take the sine of this angle and it's the opposite over the hypotenuse, right? Please, y'all are in honors pre-cal. Please do not freak out because it's letters. You learned literal equations, which are equations with a bunch of different letters in Math 1, okay? Oop, I put the wrong letter. There we go. If the letters are confusing you, this is exactly why I led off with the blue and green. Look up here. We're doing the same thing. So you cannot find the area of a triangle until you know the height. So I'm trying to find the height. I'm doing sine of that base angle equals the opposite over the hypotenuse, H over A. So everybody look, what is H going to end up equaling for this brown one? Good. A sine, don't call it Y. That's gamma. You can call it C if you want. It's the Greek angle C. So A sine C. All right, does everybody agree that's what the height would be? If we had numbers, we could actually find it, but we don't have numbers. We just have letters. Yes, because the height is always going to be the opposite. And you should always know one of the hypotenuses. Yep, good question. Yes. No. I'm showing you where this equation comes from. That's what the word derive means. I'm showing you how they got this. So everybody look, do y'all agree that for any triangle, if we know two sides and the angle in between them, this would be the height? That's why I'm using all letters because it works for every triangle, okay? So watch this. Area is 1/2 base times height, right? Okay, what did we just get for the height? That works for any triangle. A sine of C. So look, y'all, this is how they got their formula. 1/2 base times A sine C. They just have A written first because it's in alphabetical order. But that's where it comes from. They found the height first, and then they plugged it in to the area formula. So this is why I said, if you're good with SOHCAHTOA and you want to find the height every single time, you do you. I'm not going to do that. I'm going to use this right here. 1/2 A times B, the two sides, and then take the sine of the angle in between them. Because that sine of the angle in between them, that would give you the height. I'm just showing you where the formula comes from. Guys, old math teachers did not do this. I can tell because y'all are like, oh, that's not good. I'm going to have to rein my people in. How many of you like seeing where it comes from? Rodney is like, I don't really care. I don't like giving you a formula and saying memorize this ish. Y'all know I like you to know where it comes from.
I like knowing where it comes from.
I know you do, Kendall. That's what makes you an excellent learner. Is everybody in agreement that this is our area of a triangle? We used what you learned in middle school, solved for the height for any triangle that we know side, angle, side. You can use this, whatever the hypotenuse is, sine of that angle, that's the height. And so I plugged it in. So for all of these, this is the formula I'm going to be using. How many of us are not great at memorizing formulas? So if you forget, you use SOHCAHTOA, find that height, and then you can find the area. Okay? All right, let's do an example. This was literally your notes for today, though. All right, I got 2 examples, and then we're gonna make sure we're all good with application problems, and then y'all will be good to work on your work. All right, I want you to find the area of a triangle where A is 5, C is 7, and angle B, beta, is 70 degrees. I love what I'm seeing. I got a lot of people drawing it. If you are not a visual learner, then you could see A, C, and angle B. Angle B should be in between them, right? But my people that are visual, like me, I'm visual, I need to draw it. I've got A is 5, C is 7. That means this side would be B, right? Okay, which means this angle is angle B, so this is 70 degrees. All right, so everybody look at me. My non-formula people, could you use SOHCAHTOA, do sine of 70 equals h over 5 and find your height? Absolutely. But my people who are okay with formulas, we can cut out that middle step and just go straight to this right here. So to find this area, all you have to do is 1/2 times 5 times 7 sine of 70.
So does the formula work for every angle across from the sides, or does it only work for gamma?
Side angle side. You have
Okay.
to have side angle side to use this formula. Yep, good question. But make sure you know 2 sides and the included angle to use this. Yeah. Right. Yep, that's just a general equation for this. You need 2 sides and the angle in between them. We okay? All right, did y'all type this into a calculator or Desmos? Chop, chop, type it in. Are you in the right mode? I got something different.
No, I did.
Gotcha. One half times 5 times 7 times the sine of 70 degrees. Anybody got an answer? Look at Ross go. 16.44 units squared. That's what I got. Rodney, is that what y'all are getting? Perfect. Yeah, that's fine. You can put U squared for units squared. Just make sure y'all pay attention to the units, because every year on the test, and there's one this year too, there's a multiple choice problem that talks about area. And it'll say like feet squared, units squared, centimeter squared, meter squared. And I always put 2 of the numbers the exact same, and kids don't pay attention and pick the wrong units. Okay. What do we think about area? Easy or hard? Could y'all do that? You can use the formula. If you don't like the formula, you can use SOHCAHTOA, find the height each time, okay? All right, I'm gonna step it up. I feel like we should be ready. I'm just throwing stuff today. Example 2. Find the area of a triangle where A is 5, B is 8, and C is 11. I'm gonna move the sides around just so y'all see that it's not just A and B. It's whatever angle you have between two sides. So what's the issue with this one? There's no angle. I gave you side, side, side. I did not give you side, angle, side. So what do you have to do before you can find the area? Oh, smart kiddos. Law of cosines. Find an angle. Does it matter which angle? So just so we see something different, I'm not going to do the one on the left. Are y'all okay if I do the one on the right? You could also do the one on the top. Doesn't matter. So my people that are not the formula people and you want to use SOHCAHTOA, I'm totally fine with that. That was me when I took pre-cal. To find this height though, you have to know one of these angles. We're looking, right? Okay. So I'm going to find this one right here just so y'all see one on the other side, a different one. Okay. So how do we find X using law of cosine since it's side, side, side?
8 squared plus 11 squared minus 5 squared. All of that over 2 times 8 times 11.
I'm so proud of you. Did you look back in your notes?
No.
Good. He's got a pattern. It's just a pattern. So now that y'all have been practicing the pattern, if you do take the pre-cal exam, I really don't know still, they give you a formula sheet and this is up there. Law of cosines is up there. You're welcome. I made you learn the pattern for no reason. Ha, now you know it. Now you won't forget it, right, Oswald? There we go. All right. You can type all of this into Desmos and take the cosine inverse to find what angle X would be. So remember, you can go to desmos.com on your phone. It's a graphing calculator on your phone. You can get to it on a tablet, on a computer, anything. People at home, do y'all need to see me type it in?
No, I don't think so.
Okay. Just let me know if you do. I'm going to use a calculator then so I don't have to switch my screen. So I actually have not done this one yet. Minus 5 squared divided by. All right, for angle X, I'm not rushing you. Keep doing it because I like that y'all are practicing. I got 24.62 degrees. That's rounded though. Good, that's what you got, awesome. Okay, can we talk about this really quick? We're gonna have to use this angle to find the area. So should I be rounding it? No, so this is where if you use a calculator, you need to store that angle. If you use Desmos, you're gonna copy and paste the whole angle. Do we understand? Okay. But now we know this angle right here. So everybody look at my triangle. Now don't I have side, angle, side? So you can use that formula I gave you. 1/2 11 times 8 sine of that angle. If you don't like the formula, I don't want to force anybody to use the formula. Let's make that clear because I didn't use it when I was a student. If you don't like the formula, now you can do SOHCAHTOA to find your height, okay? And then you can do 1/2 base times height. I hope they were listening. They were all working so hard. Y'all were listening, right? You do not have to use the 1/2 AB sine C. You can do SOHCAHTOA, find your height, and then do 1/2 base times height. Do it whichever way works best for you. Everybody a second to try it. What'd you get? Y'all can't see, but Ross is so happy, smiling underneath his mask. He's like, I like this unit. Who would have thought? Because you hated geometry and math too. Are you guys getting 18.33? Did anybody use SOHCAHTOA to find the height and still get that? Would anybody like to see that? Yes, you want to see it? Okay. I'm going to do it. Can I do it down here in brown? Okay, so to find the height, if you're using the SOHCAHTOA way, you would do sine of x equals h over 8. So you still have to use law of cosines to find that angle, right? But then I can do sine of x because I got the opposite and the hypotenuse. So sine of x equals h over 8. So then h is just going to equal 8 sine of x. So when you plug it into your area formula, 1/2 times the base, which is 11, times the height, which is 8 sine of x. It's the same thing we did up here. Doesn't matter that the 11 and 8 are switched because you're just multiplying. It's commutative. Okay? So you'll get the same exact thing as long as you did your SOHCAHTOA right. All right, I'm going to leave this up to y'all. Do we need to see an application problem with a right triangle, or we think we can do it? Let's just do one. Okay, that's fine. I'm going to make one up. You'll still have plenty of time. This will only take like 2 minutes. We'll use Natalie as our example. It's H-A-L-I-E, right?
N-A-T-A-L-I.
Okay, no H. A girl in my 3rd period, her name's Natalie, and she has the H. And I always get y'all confused. So I'm so glad I'm not writing your names on papers because I'd be like, oh my God. Natalie is looking up at a flagpole. Great. At a, I was going to roast you and be at a 90-degree angle because you're so short. I'm so funny. All right. At a 27-degree angle. My husband does not think I'm funny at all. He's like, girls aren't funny. Please shut up. At a 27-degree angle, the flagpole casts a shadow of 15 feet. How tall is the flagpole? So I'm going to let you guys write it, try to draw a picture, and solve it. While y'all are doing that, I'm going to pass around the homework worksheet. Does it say anything about area? Why are all of y'all drawing oblique triangles? I didn't ask for the area. This is just a regular application problem. Doesn't have to be just on area. So the problem is talking about Natalie. Here is Natalie. She's looking up at a what? A flagpole. Flagpoles are vertical. You can draw you a little nice flag. There we go. Ta-da. Where does a shadow go? On the ground. Please do not draw the shadow as the diagonal piece. Your shadow does not float up in the air. That would be scary. That's some demon mess, okay? The shadow is on the ground. So here's the flagpole shadow. And Natalie, I drew her kind of tall. Let's put her right here. That wasn't a dig. You were floating in the air. Natalie is looking up at the top of the flagpole. This is what your picture should have looked like. We're not drawing oblique triangles. A flagpole is not tilted. If it is, it's going to fall. You need to build a new one. Capiche? Application problems can be any kind of triangle. Some of them might be oblique, but if we're talking about a tower or a flagpole or something that's vertical, and then somebody's looking up at it, they're on the ground, that's going to be a right triangle. Is everybody with me there? All right, Natalie's looking up at 27 degrees. The flagpole shadow is 15 feet long. How tall is the flagpole? We want to find the opposite side. Is everybody with me there? It said nothing about area. I don't know why y'all were trying to draw area stuff. Oh, Children. I'm not picking on you. It was 4, y'all. Huh? Good, Ross. You just made up for it. I'm so proud of you. You had a good math 2 teacher. Tangent of what? 27 equals, good, x over 15. So how would you find x, the height of the flagpole? Good. 15 tangent 27. Natalie, I'm really glad we did this because they needed it. And some people were mad. That's a short flagpole. If you do 15 tangent of 27, you should get 7.64 is what I got. Yes. Huh? Then it would tell you that. Very good question. If Natalie's not standing at the endpoint of the shadow, it would say the shadow goes in the opposite direction of Natalie. And so then you would have an oblique triangle. Good question. So are we okay with the application problems? Okay, my kids online, before you leave, and my kids in person, y'all better be listening. You do not, because you guys have hard copies, you do not need to do 6 and 10. Mark them out. Now, freeze, my online people, if you don't have a hard copy and you're watching this video later or you're on right now, I already took those off of the one that's in Canvas. So the worksheet should be 10 questions long that you're doing, okay?